the ultra-black fish that absorb 99.95% of light. In 2020, marine biologists caught a fangtooth. It's a deep-sea fish with a mouth full of teeth. Karen Osborne, the lead researcher, wanted to take a picture. She couldn't. The fangtooth turned into a living black hole before the camera. The outline was there, but not the fine details. It was as if the fish was devouring light. Osborne was confused. This wasn't her first photo shoot with a deep-sea fish, but then she remembered having this problem before.
I had tried to take pictures of deep-sea fish before and got nothing but these really horrible pictures where you can't see any detail. How is it that I can shine 2 strobe lights at them and all that light just disappears?
The fangtooth is one of 16 such species found by Osborne. These deep-sea dwellers camouflage themselves. Their skin is ultra-black. One species absorbs 99.956% of the light that hits it. This is more surprising than it sounds. These fish live in a place where sunlight doesn't penetrate. Why would they need to be ultra-black in total darkness? But the reality is that the ocean's depths do have light. It's just not sunlight. The depths are aglow with bioluminescence. It's the light produced by various organisms, from bacteria to fish to squid. This light show serves a wide array of purposes. Some species spew a cloud of luminescent goo. It confuses their hunters or even sticks to their bodies. This marks them for their own predators. Other deep-sea fish throw off luminescent beams from their faces. These act like searchlights that help them find food. The anglerfish is probably the most famous example. It uses a glowing lure to draw prey into its jaws. The males and females of some species light up to find each other. Most bioluminescence is blue. Blue light propagates farthest in these waters, but all this light attracts attention, both for prey and predators. That's where ultra-blackness comes in handy. The fish's own light doesn't show its face. The prey doesn't see the predator until it's too late. This pigment responsible for this camouflage is melanin. It's the same stuff that gives humans our skin coloration. This skin of these 16 fishes is packed with a layer of organelles. They are called melanosomes and loaded with melanin. The melanosomes absorb most of the photons, but what isn't absorbed scatters into the layer. It gets absorbed by the neighboring pigments. They're all packed right up close. Karen Osborne says,
What they've done is create this super efficient, very little material system, where they can basically build a light trap with just the pigment particles and nothing else.
Incredibly, the 16 ultra-black species aren't related. They evolved this ability independently. Their melanosomes are arranged differently in the skin. Some of them have just a big jumble of the pigment cells. Some have 3 layers, others only 2. Some have thick layers, others have thinner layers. But the skin of all these species is light absorbent. It's specifically tuned to absorb blue and green light. These are the colors of the majority of bioluminescence in the deep. Some species even have ultra-black gut linings. This keeps them from glowing when they eat bioluminescent prey.
You don't want to be swimming around with a glowing belly, right?
Says Osborne.
That's just asking for trouble.